everyone. So in this tutorial, we are going to see how to utilize Bootstrapped historical simulation. Last time I remember, if you have seen my previous videos, we have done historical simulation, and we at the time we have taken a portfolio consisting of dollar INR and dollar JPY in the scenario of in which is 60% and 40%. So total portfolio amount was 1 million US dollar, and we have taken it, and we learned how to uh, apply historical simulation here, and we found out 90%, 95%, and 99% VAR and restricted short for using this. This time we are just going to see what is bootstrap historical simulation and why it is used over this normal historical simulation. So what we are going to do in bootstrap historical simulation, that we are going to resample those historical returns, and we are going to just generate a new kind of alternative history. So basically, so it is basically a historical simulation, but with more data generated from the same history. You will going to see that how it is being used here, okay? And why the problem? Why there were a certain problem with historical simulations? So it is using whatever returns, historical returns only one time, okay? It has limited scenarios for 250 days. It is going to have only 250 outcomes, and there is also that it is not good for estimating, particularly VAR, 99% VAR. So that's why what does what does Bootstrap for historical simulation improve upon historical simulation is that it is going to create a lot of more scenarios. It is going to improve tell stability, and it keeps empirical distribution. So just let's see. So if you have checked how these change in dollar INR or change in dollar JPY is calculated, these are just some. So these are basically returns from previous day. And okay, we can do we can apply it for all those cells, and we can just copy paste it here. It will again, okay, and this portfolio consists of 60% of dollar INR and 40% of dollar JPY. So we have taken formula here. We are going to calculate the portfolio return. For example, for first day, we got 0.01% dollar INR return. Okay, it was negative. And similarly, we similarly got dollar JPY return as well, negative 0.61%. Overall, our portfolio decreased by 0.25%. Cool. And now what we are going to do is we are going to replicate these portfolio returns. Okay. And we want to take some random portfolio returns out of these. Okay. So I'm just creating a separate column. Bootstrapping. I'm going to take index this array. I've selected previous returns. Now I'm going to give a random number between. I'm going to select random rows. Okay. So let's say bottom 1 to 62. Okay. Yeah. Oh, we forgot. So it randomly given our one of the scenarios, one of the portfolio returns. So each time I'm doing, it is giving me some random returns from these. These I think these were 262, right? Let me see, 261 to be exact. Okay, I can just put it. 61. Okay. I can drag this formula and I'm going to get random numbers. Bootstrapping. Cool. So every time I press F9, I'm going to find out some different values. So guys, I'm going to calculate VAR right now. So we calculate around 250 random sampling. Okay. So I'm just calculating VAR 95. Also calculate VAR 99%. I'm going to run around 1000 simulations. How VAR 95% will be calculated here. One minus 0.95. We got these values and it's a return in percentage term. We are going to convert into portfolio VAR. For simplicity, should I convert it to dollar? Let's fix these columns. And I'm going to calculate 99% VAR, percentile VAR. I'm going to run now. I'm going to run this simulation for 1000 times. And we're going to fill up this table using func the what if analysis in data. Just we can just input any random cell and it will going to populate this gold table and it is going to run simulation 4000 times. Yeah, it took a little bit time. Okay. So why I have run this 1000 times? So if you see, this was the VR we found out from this bootstrapping, and every time if I press F5, sorry F9, it is changing rapidly. See, so like there is a lot of fluctuation. So that's why I ran it to for 1000 times. What I'm going to do is right now I'm going to take an average for it. Okay. Similarly, same for VR 99%. Let's make it little green. Okay. So if I see right now, these values won't fluctuate much. You see, average VR is constant right now, and these are not fluctuating much. So if I again just so we found out that for this particular portfolio, value at risk for at 95 percentile is 5,700. So the $5,075.82, and at 99 percentile it is near about 9,325.89 US dollars. Okay, cool. If you want to check out what are the advantages of Bootstrap HS? So we did not take any kind of distributional assumption like normal or any kind of assumption distribution. We did not take it. We just simply take PCS data. So it has much more richer tail estimation. So we just found out that how VAR was initially jumping a lot, and now after taking so many simulations, we found that our average value is not changing that much. Another thing is it is very conceptually simple to understand. You just know that there are a few tweaks that you need to do, and it's very simple. And then also it's computationally easy. So we did this. We ran 1,000 times in say, Excel only. Some of the limitations include it assume that returns are independent of each other, which are so it assumes the returns are IIDs. It is not that which should not be the case. Okay, and it takes account the previous volatility, not any kind of forward-looking volatility. For example, take the example of COVID. For example, in India, everything was good up to February 2020. Then in March, what happened? Lockdown. Okay, and until then, the market starts uh, like selling started happening in markets. But if at that particular point of time, if we would have applied this historical simulation, it would have showed a different kind of VAR. So it does not take account in the current volatility, and there is always a noise in Bootstrap. So we've just checked out how VAR that we just found out was jumping a lot. So there are a few scenarios where you can use this. So basically, you don't want to put it in any kind of particular distribution. You don't want to put any kind of parametric assumptions. You in your particular portfolio, there is a relative stability. So you can just take example for around 2023 till 2024, there, in dollar INR, there was a period which was very stable. The currency was not at all volatile. You could apply at that time. Okay. So some of the common use cases are in FX portfolios, commodity trading desk, equity portfolios with fat tails, risk reporting. So mainly all those common scenarios that we normally use other kinds of bootstrap, sorry, other kind of historical simulation methods. So one of the updation of this historical simulation is filtered simulation approach. So which we are going to see in our next video. Till then, stay with us. Thank you for watching this video.